Welcome students. In last class we have discussed the refraction of light on the basis of wave theory, and in that class I have explained you this diagram properly. So if you have any confusion with this diagram, you can ask me again. I can re-explain it to you again. Today we will derive the first and the second law of refraction. Okay, now from the right angle triangle ABC we have, consider your right angle triangle ABC, this triangle. Here this angle is 90 degree and this angle is I. So what will be I? Or your sine I? Sine I will be the ratio of the opposite side, which is your opposite side BC, divided by your hypotenuse. This is your hypotenuse AC. So sine I equals to BC upon AC. Now consider your triangle ADC. ADC, this triangle. Now in this triangle, this is also a right angle triangle. This angle is R. So what will be sine of R? Sine R equals to opposite side AD divided by your hypotenuse AC. Fine. Sine R divided by AD by AC. Okay. Now what you will do? You will divide equation 1 and equation 2. That means sine I by sine R. Now you will divide equation 1 and equation 2. Fine. So sine I by sine R, what will happen? This AC and AC term is common, so I have sine I by sine R equals to BC upon AD. Sine I by sine R equals to BC upon AD. Now your BC equals to V1T and AD equals to V2T. BC equals to V1T, AD equals to V2T. This T and this T gets cancelled. So I have sine I by sine R equals to V1 by V2. We know the ratio of the velocity in one medium with respect to another medium is known as your refractive index of the second medium 2 with respect to your first medium 1. So I can write this one as n of 2 1. So sine I by sine R equals to n of 2 1. This is your Snell's law. So we have proved the first law of the refraction. Coming to our second law. Further, the incident ray SA is perpendicular to the incident wavefront AB. Your incident wavefront or your incident ray SA is perpendicular to incident wavefront AB. The normal AN perpendicular to the surface XY. The normal AN is perpendicular to the surface XY. The refracted ray AD is perpendicular to the refracted wavefront CD. The refracted wave AD is perpendicular to the refracted wavefront CD. Now, note that this one, your instant wavefront, your surface XY and CD, they are all on the plane of the paper. Therefore, they are perpendiculars SA perpendicular to AB, AN perpendicular to XY, and AD perpendicular to CD will also lie on this plane. So what we have done, we have proved that your incident wavefront and your incident ray, the normal AN and your refracted wave or your refracted wavefront, they all lie on the same plane. This is known as your second law of refraction. Fine. So if you have any confusion, I can re-explain it to you again. Okay. So that's it for today's class. Thank you.